Good morning, everyone. Hope you are all good. Alhamdulillah, we're gonna complete this lesson with this topic. Inshallah, next week onwards, I'll try to give all the important questions along with the derivations. Okay, make sure you have that lessons 1, 2, 3 for this November monthly test. Okay, this is our portions for 70 marks. Okay, what is the we are dealing with the lessons electromagnetic waves. What is electromagnetic waves? Whenever the electric and magnetic field are perpendicular to each other and the perpendicular direction, the electromagnetic waves are propagating in the perpendicular directions. Okay, it consists of electric energy as well as magnetic energy. So we learned about the displacement current, and then how they proved that Maxwell experiment, all those things. Okay, now listen, what are the properties of electromagnetic waves? Okay, so electromagnetic waves are produced by any accelerated charges. Electromagnetic waves are produced by any accelerated charges. Okay, the electromagnetic waves do not require any medium for propagation. Important, do not read any medium for propagation. So electromagnetic waves are non-mechanical wave. Electromagnetic waves are non-mechanical wave. Okay, electromagnetic waves are transverse in nature. Electromagnetic waves are transverse in nature because whenever the electric field in this direction, the magnetic field perpendicular to the electric field, then electromagnetic waves will be perpendicular to this paper plane out. Okay, to electric and magnetic field. This is electric field and this is magnetic field. This is electromagnetic waves. Okay, so next one thing, vector, oscillating magnetic field vector and propagation vector are mutually perpendicular to each other. For example, if electric and magnetic field are shown in figure 5.8, then the direction of the propagation will be along x directions. Okay, remember. Next one, electromagnetic waves travel with the speed which is equal to speed of light in vacuum. Okay, always you know that even though when you switch on that, the electricity will pass through the speed of light. Okay, epsilon naught is the permittivity of free space in vacuum, and mu naught is the permeability of free space, where epsilon is the permittivity of the medium. Okay, electromagnetic waves are not deflected by electric and magnetic field because they are neutral charges, so they never deflected by electric and magnetic field. Electromagnetic waves can exhibit interference, diffraction and polarization. So due to the electromagnetic waves, the wave property, they obeys that wave properties. Okay, there are the two properties which is called ray optics, ray properties, and then wave properties. It is obeys that interference, diffraction and polarization. Like other waves, electromagnetic waves also carry energy, linear momentum and angular momentum. Okay, see that. Do you know? It is surprising to realize that the EM waves have the linear momentum and angular momentum like particles. But in the year 2018, Nobel Prize Physics was awarded for invention of optical tweezers of production of high intense light pulses. Optical tweezers is nothing but laser light used to move the micro-sized particle or molecule from one location to another location. It has a lot of applications in the medical field. Okay, even though cancer cells can be separated from the normal healthy cell, the optical tweezers utilize momentum property of EM waves. In fact, the comet has tail shape because of the sunlight import large amount of linear momentum which pushes the masses of the comet away from the sun. Angular momentum of the EM waves can be understood in simple way. Consider the step up oppositely charged coaxial cylindrical cells. Okay, and in between them the solenoid is kept. The AC current is flowing through it, and when the current solenoid is reduced to zero, then the inner and outer cylindrical cells start to rotate in the opposite direction. The rotation of these cylinders is due to the import of the angular momentum from the electromagnetic field produced by the AC current. Okay, and source of electromagnetic waves, already we know that the stationary charges produces only the electric field. Okay, stationary charges only produces electric field around that, but electromagnetic waves is produced by accelerated charges. Produced by Q is produces only that electric field charge, the stationary charge. Okay, but electromagnetic waves are produced by accelerated charges. Look at the picture. There are the two plate is act as a capacitor. Okay, so the capacitor is a discharging of spark oxidative molecular dipole. When E naught and see The particle accelerator produces a magnetic field addition to that electric field. Both electric and magnetic field are time varying fields. Since the electromagnetic waves are transverse in nature, the direction of propagation of electromagnetic waves is perpendicular to the planes containing electric and magnetic field vectors. So Ex equal to E naught sin kz minus omega t and By equal to B naught sin kz minus omega t, where E naught and B naught are amplitudes of oscillating electric and magnetic field. K is the wave number. Okay, I'll tell you what is that wave number. Omega is the angular frequency of the wave. Okay, so listen, look at that one. Now the both electric and magnetic field are oscillate, so C is absolutely E naught by B naught. Okay, we know that already. So from the Lorentz force, from that Lorentz force only. When compared with the Lorentz force and the centripetal forces in the cyclotron, we will get the velocity of that electron or velocity of that particle in a uniform magnetic field and uniform electric field. So C equal to C is nothing but speed of the light, which will be equal to electric field by magnetic field. Okay, when it's in the medium, whenever the light in the vacuum, speed will be 3 into 10 power 8 meter per second, but in case of in the light in the medium, it will be reduces. Okay, so because of that medium having the refractive index, it depends upon the refractive index, the speed of light will be decreases. The energy of the electromagnetic waves comes from the energy of the oscillating charges. The next one, this phenomenon is known as electromagnetic spectrum. Okay, look at the picture. Electromagnetic spectrum. Okay, the radio wave, microwave, infrared, visible light, UV ray, X-ray, gamma ray. Look at that frequencies ranges and then wavelength of that. Okay, radio. Roy married Indian, visited USA, experience good. Okay, Roy married Indian, visited USA, experience good. Radio wave, microwave, infrared, visible light, UV ray, X-ray, gamma ray. Look at that. Electromagnetic spectrum is an orderly distribution of electromagnetic waves in terms of wavelength or frequency. Okay, based on the wavelength or frequency, we have to order them in a sequence manner, then it is called electromagnetic spectrum. Radio wave, they are produced by accelerated motion of charges in conducting wires. So by the conducting wires, accelerated motion of charges when they are conducting wires, they can produce the radio waves. Okay, you can also produce this kind of radio waves in your laboratory. And also the frequency range from few hertz to 10 power hertz. Okay, frequency up to 10 power 9 hertz. To honor the Henry hertz, we can denote that frequency SI unit Henry hertz. Okay, they show reflection and diffraction. They are also used in the radio and television communication systems and also in cellular phones to transmit the voice communication in ultra high frequency band. Okay, important one. By ultra high frequency band, we can use it in the cellular phone. Then next one, microwaves. It is produced by the special vacuum tubes such as klystron, magnetron and gun diode. The frequency range of microwaves is 10 power 9 Hz to 10 power 11 Hz. These waves undergo reflection and can be polarized. Okay, it is used in the radar system for aircraft navigation, speed of vehicle. Whenever you are on the highways, you may see in the police having the gun type speedometer, right? So detect the speed of the vehicle. Microwave oven for cooking and for very long distance wireless communication through satellites, also used in the satellites. Okay, the infrared radiation, it is produced by hot bodies. Okay, it's produced by the hot bodies or heat waves, and also by when the molecules undergoing the rotational and vibration transition. Okay, this frequency ranges will be 10 power 11 Hz to 4 into 10 power 14 Hz. It's provide the electrical energy to the satellites by means of solar cells. Okay, whenever there is a satellites revolve around that earth, it needs some energy, so they gain the energy from the solar panel. What is a solar panel? Solar panel is nothing but it convert light energy into electrical energy, and also it is used to produce dehydrated fruits and in greenhouses to keep the plants warm, heat therapy for muscular pain or sprain, TV remote as a signal carrier. You may see in the TV remote they have the LED bulb with a red color, right? So it's nothing but infrared. to look through the haze, fog or mist and used in the night vision or infrared photography. Okay, you mentioned a lot of the CCTV camera have been implemented with the night vision photograph, because during the night time without this light effect we can't take the photos, right? During the by using the infrared we can measure everything. Okay, we can take the capture, we can capture the photographs with high quality. Okay, infrared photographies. Visible light, it is produced by incandescent bodies and also is radiated by excited atoms in gases. The frequency range is from 4 into 10 power 14 hertz to 8 into 10 power 14 hertz. It obeys laws of reflection and refraction. It undergoes interference, diffraction and can be polarized. Okay, this one obeys everything. It exhibits a photoelectric effect also. So see what? So visible light is nothing but our sensation of eyes vision. Okay. It is used to study the structures of molecules, arrangement of electrons in the external cells of atom. Look at that. External cells of the atom. It causes the sensation of vision. Okay. The ultraviolet radiation. It is produced by sun or on ionized gases. Its frequencies range from 8 into 10 power 14 hertz to 10 power 17 hertz. Okay, and what is the uses of this one? It has a less penetrating power. It can be absorbed by atmospheric ozone and is harmful to human body. It is used to destroy the bacteria in sterilizing the surgical instrument and theft alarm, that means burglar alarm, and to detect the invisible writing, fingerprints, and also used in the study of atomic structure. X-rays, the well-known rays, okay, which is found by the William Röntgen in 1905. It is produced when there is a sudden stopping of high-speed electron at a high atomic target. Okay, when the fast-moving electron hit or strike the high atomic power target, then high atomic number target, then it produces the rays. It's called X-rays, and also is by electronic transitions among the innermost orbits of atom. The frequencies range of X-rays from the 10 power 17 hertz to 10 power 19 hertz. X-rays have the more penetrating power when compared with ultraviolet radiation. X-rays are used to extensively studying the structures of inner atomic electron cells. Okay, the visible light used to study the external cells of the atom, electrons in the external cells. Okay, this one we are using to inner atomic electron cells and crystal structures. It is used to detecting the fractures, diseased organs, formation of bones, stones, observing the progress of healing bones also. Further, in a finished metal product, it is used to detect the faults, cracks, flaws and holes. Gamma rays. It is produced by the transition of radioactive nuclei and decay of certain elementary particles. Okay, they produce chemical reactions on photographic plates. Okay, fluorescence, ionization and diffraction. The frequency range is 10 power 18 hertz and above. Gamma rays have the higher penetrating power than the X-rays and ultraviolet radiation. It has no charge because it's the neutral charge, okay, but harmful to the human body. Gamma rays provide the information about the structure of atomic nuclei because it can penetrate throughout the atom because it has no charge, okay. It is used in the radiotherapy for the treatment of cancer and tumor. In food industry, it is used to kill the pathogenic microorganisms. Okay, and the next one we call, that is called types of spectrum. Emission and absorption spectrum and Fraunhofer lines. What is the types of spectrum? When an object burns, it emits radiation. Exactly, we know that. Okay, when the object burns, it exactly emits the radiations. That is emits the electromagnetic radiations with depends on the temperature. If the object becomes hot, it glows in red color. If the temperature of the object is further increased, if you are increasing that one, it can be glows in the reddish orange color and becomes white when it's the hottest. Okay, look at that. Infrared have the 3000 to 4000 Kelvin, but ultraviolet having this kind of things, but 6000 Kelvin, the inner core of the body also, that is surface of the outer core. Okay, 6000 Kelvin. That black body radiations of spectrum, variation with the temperature. This is called black body spectrum. Suppose we allow the beam of white light to pass through the prism. It split into the 7 constituent colors which can be viewed on the screen as continuous spectrum. This phenomenon is known as dispersion of light, and the definite pattern of colors obtained on the screen after the dispersion is called spectrum. Okay, the spectra is classified into 2 types. First one is called emission spectra. When the spectrum is self luminous source taken, okay, from the direct source we get the emission spectrum. Each source has its own characteristics emission spectrum. This emission spectrum can be divided into three types. First one is continuous emission spectrum. Continuous spectrum, if the light from the incandescent lamp or filament lamp is allowed to pass through the prism, okay, when you are taking the white light through allowed to pass through the prism, it splits up to 7 colors with GR, right? Violet, indigo, blue, green, yellow, orange, red. It split up to into 7 color. Thus it consists of wavelength containing all the visible colors ranging from violet to red. The examples, the spectrum obtained from the carbon arc or incandescent solids. Line emission spectrum or line spectrum. Suppose the light from the hot gas, okay, hot gas is allowed to pass through the prism, line spectrum is observed. Line spectra is also known as the discontinuous spectra. The line spectra consist of sharp lines of definite wavelength or frequencies, okay, it must be have the definite wavelength or frequencies. So spectra arise due to the excitation of atoms. These lines are characteristics of atoms are different for the different elements, okay. For different for hydrogen atom they have the different types of characteristic, and then for the ammonia they have the different types of, okay. The excited of atoms, it was happened only when the atoms are excited, okay. So spectra of atomic hydrogen and helium. Band emission spectrum, this only happens due to the excitation of molecules, okay. So band spectrum consists of several number of very closely spaced spectral lines which overlap together forming the specific bands which are separated by the dark spaces. Look at the picture. Line spectrum, okay, you may see in that hot gases when pass through the prism, you may see in the dot lines, straight line, the narrow lines is called line spectrum, okay. I'll show this one, we call as band spectrum. The band spectrum is this spectrum has a sharp edge at the one end and the fats of the other end. So spectra arise when the molecules are excited. Band spectrum is a characteristic of the molecule, and hence the structures of the molecules can be studied using their band spectra. So example, spectra of ammonia gas in the discharge tube. When the light absorption spectra, the second one is called absorption spectra. When the light is allowed to pass through the medium or an absorbing substance, then the spectrum is obtained is known as absorption spectrum. Spectrum is known as absorption spectrum. The characters of absorbing substance or absorption spectrum classified into three types. The first one we called continuous absorption spectrum. When we pass the white light through the blue glass plate, okay, it absorbs all the colors except that blue, gives the continuous absorption spectrum. Look at that one. When we pass through the light to the blue glass plate, okay, what will happen? It absorbs all that one except that blue. Line absorption spectrum. When the light from the incandescent lamp is passed through the cold gas, okay, medium, it's like a medium, it's absorb all the things, and then the spectrum obtained through the dispersion to the prism is line absorption spectrum. Similarly, the light from the carbon arc is made to pass through the sodium vapor. It sodium continuous spectrum of the carbon arc will two dark lines in the yellow regions are observed, okay. This kind of yellow regions will be observed instead of all the colors is observed with two yellow lines only, okay. Band absorption spectrum, when the white light passes through the iodine vapor, okay, solid states, dark bands on the continuous bright background is obtained. This type of band is also obtained when the white light passed through the dilute solution of blood or chlorophyll, or through certain solution of organic or inorganic components. Ferrophyllines. This is very, very, very important. Two more questions. Ferrophyllines. When the sun is examined, okay, the spectrum obtained from the sun is examined, what will happen? When you are looking at the sun for the longer time, you may see in the dark lines, or the center, look at the center will be in the darken, okay. Why? Because of inner core of the sun, okay. Inner core of the sun have the much more temperature. This look like inner core is called chromosphere, having the temperature of 10 power 14 Kelvin, but outer core it is called photosphere, having only 6000 Kelvin, okay. Whenever there is inner core have the much more hotter than the outer core, so they continuously producing the waves, okay. Continuously they producing the waves. See, when the spectrum is obtained from the sun is examined, it consists of large number of dark lines. The dark lines of solar spectrum known as Fraunhofer lines. The absorption spectra are various materials are compared with the Fraunhofer in the solar spectrum with identifying the elements present in the sun atmosphere. Why is happening like that? Because of inner core producing the continuous spectrum. When the outer core is compared with that inner core is the coolant to place, so it absorbing that lines and dark lines will be observed. Dark lines will be seen from that materials. Okay, so that's why it is called Fraunhofer lines. Okay, this is two more question. Alhamdulillah, we almost complete these lessons. Okay, inshallah, next week class onwards I'll take that first lesson, second lesson, third lesson, important 5 more questions. See, note it down. This one is very important. Electromagnetic waves are transverse in nature. The oscillating magnetic field of vectors are directly mutually perpendicular to each other. Okay, this one it can be shows interface diffraction can be polarized. Vector carry not only energy momentum and angular momentum. There is a two type of spectra. It is called absorption spectra and emission spectra. Okay, so this is also important 2 more question. Okay, so listen guys, read well. We'll discuss in the person. Okay, Allah Hafiz, take care.